Hello everyone. Today, we will demonstrate our QGIS plugin called Fast Density Analysis. The number of downloads of this plugin has reached 17,500 plus, showing that many GIS experts have adopted this plugin. Fast Density Analysis supports three analysis tools, which are Kernel Density Visualization (KDV), Spatiotemporal Kernel Density Visualization (STKDA), and Network Kernel Density Visualization (NKDA). We will first show how our plugin supports each tool for analysis. Then, we will vary the bandwidth parameter to examine how these parameters affect visual quality. Lastly, we will compare the efficiency of our QGIS plugin with the state-of-the-art QGIS plugin. Let us consider KDV. Here, we use the Hong Kong COVID-19 dataset as an example. Click the icon from the plugin and select Kernel Density Visualization to launch the interface. Here, we first select the dataset Hong Kong in the input point layer. Then, we specify the longitude and latitude fields. We set the resolution size and the spatial bandwidth to be 800 by 640 and 1000 meters, respectively. Lastly, we can click Run to obtain the KDV result. Observe that Fast Density Analysis produces a high-resolution KDV of COVID-19 events in Hong Kong. Note that many geographical phenomena depend on event time, for example, different waves of COVID-19 cases. Therefore, domain experts adopt STKDA for analyzing their location datasets. In Fast Density Analysis, we also offer this functionality. Here, we reuse the same settings as KDV, for example, the 800 by 640 resolution size and 1000 meters as the bandwidth. Additionally, we need to set the attribute name in the time field, the number of timestamps in the time axis field, and the starting time and ending time for analysis in the start and end field. Within a few seconds, our plugin returns 8 hotspot maps, which correspond to 8 timestamps. These hotspot maps reveal how COVID-19 hotspots emerge, shift, and dissipate over time. Many geographical events, for example, traffic crashes, are restricted to a road network. For these datasets, domain experts need to adopt NKDA for road network analysis, which has also been supported by our plugin. In this demonstration, we adopt the New York traffic crash dataset as an example. By providing the dataset, the layer name, the bandwidth, and the pixel size in the corresponding boxes, we can obtain the result by clicking the Run button. After waiting about 2 minutes, including 1.5 minutes for downloading and preparing the road network data, we can obtain the NKDA result for this large-scale dataset, with 0.26 million data points. Now, we examine how the bandwidth parameter affects the visualization quality of KDV. Here, we see that we can generate multiple KDVs by setting multiple bandwidths, namely 250 meters, 500 meters, 1000 meters, 2000 meters, and 4000 meters. Observe that KDV is significantly affected by this bandwidth parameter. The larger the bandwidth value, the larger the hotspot region. We further demonstrate how our plugin outperforms the state-of-the-art QGIS plugin. Here, we use the Chicago crime dataset, with roughly 8.33 million data points, as an example. We set the resolution size to 1280 by 960 and the spatial bandwidth to 1000 meters. Here, we run the state-of-the-art QGIS plugin. Observe that this plugin takes more than 27 minutes to generate the KDV result. Now we call our plugin. Under the same settings, we note that our plugin produces the KDV result with 1 minute, which achieves 27 times speedups compared with the state-of-the-art plugin from QGIS.